So with multiplication, you are basically just reducing any top to any bottom and then multiplying across. So think about when you were multiplying fractions. So when you first started multiplying fractions and you had something like this, all right, you can reduce top to bottom, that 14 and 12 could reduce, or you can reduce across, right? And so you can say, well, 2 over 7, that doesn't reduce. Well, 14 over 2, that does. I can reduce by 2. That's 7 and that's 6, right? But when you're multiplying, something else happens. You can multiply cross-canceling. Any top can cancel with any bottom when you're multiplying fractions. And so if I were to do this guy right here, I would say, well, those 7s can cancel. And I can reduce this with that. And so when I multiply cross, this is technically 1. 1 times 1 is 1. 1 times 3 is 3. That actually reduces to 1/3 because I can cross cancel when I do multiplication. The same is true for rational expressions, all right? When you have rational expressions, you can cancel any top to any bottom, all right? As long as you're multiplying. And so when I look at this and I look at my numbers, well, 8 and 5 does not reduce. 25 and 2 do not reduce, but I can cross reduce. I can say, well, 8 reduces with the 2. I'm going to make this a little bit bigger. So if I were to do this and cancel these, I can say any top to any bottom. My 8, they're both divisible by 2. So I can say that's a 1 and that's a 4. My 5 and 25 are both divisible by 5. So I can reduce those. Top to bottom variables. This A can't reduce with the thing below it, but can reduce diagonally. 3 of my A's can cancel. 3 of my A's can cancel there. My B's. I have B here and B here. Those cannot cancel. They are both on top, okay? You can only cancel top to bottom. However, this C can cancel. Both of those will cancel, and I now only have 2 up here. All right, and so I'm going to double check and say, did I cancel everything that I could? And I'm going to go and multiply across. Once I'm done canceling, I like to go through and make sure I accounted for everything. So for my numbers, it's 4 times 5. That's going to be 20. I have a B here and a B squared here. B times B squared is B cubed. I have just a C to the second power, so that's there. And then on bottom, I have 1 times A. And so that is my answer there when I am multiplying. So you could multiply everything across and then reduce at the end, but you're going to have much larger numbers. So canceling is the method that you're going to want to use here. Polynomial. So I'm going to take my polynomial. The first thing I'm going to say is there anything in common? Well, obviously between 5x squared, 5x, and 100, I can take a 5 out. So I'm going to start by factoring out that 5. And I have x squared minus x minus 20 here. All right. On the bottom, a common factor, 3, 6, and 24. A 3 can come out. I have 3, x squared plus 2x minus 8. Over here, I have a 3 that can come out, and we have an x minus 2, and we have an x. And then I'm going to say, can I keep factoring? That's really what I'm looking for. Does this factor? It does. Factors of 20 that subtract to give me x, that's negative 5 and positive 4. So I have the 5 out there, and I have x minus 5, x plus 4. Here, factors of 8 that subtract to give me 2. Well, that's positive 4 and negative 2, sorry. Over here, these are as factored as we can get them. Those can't factor anymore. And now that I have everything completely factored, I am going to see if anything can cancel from top to bottom. Any top to any bottom. So I'm going to say, does this 5 cancel with anything below it or across? It does not. And so I'm going to make sure that I know that's in my final answer. This x minus 5, does that cancel? It does not. So that is also part of my final answer. X plus 4, can it cancel with any bottom? Yes. This cancels with that. All right. And you can either go across or you can go down. This 3, it will cancel, right? That's going to cancel with that. X minus 2, that's going to cancel with this x minus 2. This x does not cancel with anything. So that is also part of my final answer. If you don't have some method to make note of what's part of your final answer, something's going to get lost in there. So you'll notice I'm circling or boxing. I'm making a note that that needs to go across when I multiply. And then I literally just multiply across. I do want to point out that when you cancel things, they actually turn to a 1. They don't turn to a 0. This is really only important when everything on top cancels, because other than that, you're multiplying by 1. But if everything on top cancels, you technically still have a 1 in your numerator. So then you're just going to multiply across 5 times x minus 5, and you can leave it in factored form. And on bottom, everything down here canceled. That's just a 1 and times x. And that is your answer. You cannot cancel this x to this x because this is part of a group. It has a plus or minus with it. So this ends up being my final answer here, 5x minus 5 over x. So the same rule that applies to regular fractions apply to rational expressions. Keep, change, flip, which means I'm going to keep this exactly the same. I'm going to change this to multiplication, and I'm going to flip this. And then it is identical to the problems we've just done. Literally, it's the same thing, right? So for this one, I am going to do my factoring just like I would, but I am going to wait until I have flipped it before I start doing anything as far as canceling. In fact, I flip it from the very beginning, all right? So I go ahead and flip this second one before I even start factoring it, just so I don't forget. Once I flipped it, I can factor. So factors of 6, negative 6 that add to give you positive 1. We're going to have a positive 3 and a negative 2. This doesn't factor, so that's done. Over here, factors of 6 that add to give you 7. And then this guy doesn't factor. And so now that I have flipped it and now factored it, I can start canceling. My x plus 3 will cancel with my x plus 3. My x minus 6 will cancel with my x minus 6. In this case, I actually don't have anything left on bottom. You'll notice I just have this x plus 2, minus 2, and this x minus 1. And so I'm just going to multiply across x minus 2, x minus 1. Or you can FOIL it, it doesn't matter. We're not going to do excluded values just yet. We'll do that a little bit later. But that's my answer. I don't have to put the 1 on bottom when that's the only thing left. So you're doing exactly the same thing. Keep, change, flip. You are keeping the first, changing it to multiplication, flipping it, and then it's literally the same process. Factor, cancel your factors, and multiply across. So I'm going to keep the first one the way it is. And I'm going to change this to multiplication and then flip the second. I would probably actually go ahead and take out my common factors just so I'm already on that. So like I would probably go ahead and write this as 6x squared plus 8x plus 16. Go ahead and take out that 2 that we have down there. Right. When you flip it, a 10 comes out. This is now going to be my numerator, so I'm going to go ahead and take that 10 out. And then denominator, I can go ahead and take out a 5. Just make sure that you are flipping it before you start factoring and canceling. Once I have this, these are all kind of easy factoring. Factors of 16 that add up to 8, what are those? Something like that, maybe. All right, factors of 5 that subtract to give me 4. Positive 5, negative 1. Mm-hmm. Yep. What about this one? Factors of 15 that add up to 8. 5 and 3. Yep, I can. And then what about the last one? Factors of 8 that subtract to give me 2. 4 and 2, yeah. All right. So this is what it's going to look like. I'm factoring everything. Any top to any bottom will cancel. So like this 2 and this 6 will cancel to 1 and 3, just like I would reduce 6 over 2 anyway. 5 and 10 would reduce the same way I would reduce 5 and 10 anyway. When I look at my groups, any top to any bottom, so like this x plus 4 can cancel with this x plus 4. It's always 1 to 1, meaning I can't cancel it again with the same guy. He's already been canceled. So this x plus 4 right here is not going to cancel with anything, right? If I go down, x plus 5, well, that can cancel all the way across with this, but this x minus 1 is not going to cancel with anything. This x plus 3 doesn't have anything to cancel with. This x minus 2 doesn't have anything to cancel with. And so when I look at my final answer, I'm going to multiply across 3 times 2. I'm going to go ahead and combine those. I can leave my groups alone. I'm not going to make y'all FOIL. All right, you can actually leave it just like that. 1 times 1, we don't even have to list that. So then on the bottom, I have the x minus 1 and the x minus 2. And this is my answer. That is considered factored form. So if it says you can leave your answer in factored form, that's what it means. You don't have to refoil it. So first of all, I understand how hideous this looks, right? For everyone who loves fractions. I mean, I actually like fractions, but if you just see that, you're like, what am I looking at? You're really looking at division, right? So if I were to do something like this, 1/2 divided by 3/4, you would do keep, change, flip. You would say, oh, well, that's 1/2 times 4/3. That's all we're doing, right? We're just keep, change, flip. And so when you write this guy, you're going to keep the top exactly the same. We're going to leave him as 1 over x squared minus x minus 6. But we're going to flip this bottom, x squared minus 9 over x plus 3. Now that it is multiplication and not division, I'm going to factor everything. 6, this is, guys, easy, right? Factors of 6 that subtract to give me 1. Yep. What about this? That's a special case. How does he factor? Difference of 2 squares. How does he factor? Yeah, 3 and 3. You're just going to do a plus and minus there, right? And then the bottom is already as factors as it can get. And then we can easily see what's going to happen. This is going to cancel with this. This x plus 3 can cancel straight down. Here I have only a 1 on top, so we're going to leave that. And I have an x plus 2 on bottom. We're going to leave that. And so that would be my answer right here. 1 over x plus 2.